Thanks everyone, and thank you for joining me today. The purpose of making this video is to create a platform where we can learn Python together. In today's tutorial, we'll be focusing on data visualization. Data visualization is a discipline of trying to understand data by placing it in a visual context so that patterns, trends, and correlation that might not otherwise be detected can be exposed. In Python, there are so many great libraries that come with a lot of features. And these features, they are interactive, live, and they can be customized. To get a little overview of this library, we have the matplotlib, we have the pandas visualization, we have Seaborn, we have ggplot, and plotly. Today we will learn how to create plots using matplotlib, pandas visualization, and Seaborn, and we will also practice them. Today we'll be using a dataset called the admission dataset. This admission dataset is on Kaggle. So if you want to get the dataset, you can go to this website on Kaggle, and if you click on download, it's just 28 kilobytes. So the first thing you do if you want to import this dataset is you need to import the necessary packages. So for today, you need to import NumPy, you import pandas, you import matplotlib, and you import Seaborn. If you go ahead to type that, if you don't have this on your computer, you can just install them by doing pip install NumPy, pandas, matplotlib, and Seaborn. So with that, you can install those packages. To import the package, you run this. So those packages are installed, and the next thing, you load the datasets. The dataset is admission_predict.csv. So you use the pd.read_csv. So if you run this, you have the datasets, and these datasets, let's look at the datasets. Let's check this dataset. So this is the dataset. It has 9 columns: serial number, GRE score, TOEFL score, university ranking, SOP, LOR, CGPA, research, and chance of admission. If you study this, if you want to see the columns, those are the columns. In these data sets, we'll notice that the serial number definitely have nothing to contribute in this case, so we can drop the serial number. So with that, we drop the serial number, and we can also change the names of the columns. Replace GRE score by GRE, TOEFL score by TOEFL, replace chance of admit to probability. So if we do the rename and we run this, yes, we have this now. So we can also look at the probability, the describe. So if you look at the describe, you see the number of datasets is 500. The mean probability is 0.72, standard deviation 0.14, and the likes. In the last video, we talked about the exploratory data analysis. Today, we will just focus on visualization. The first package we'll be talking about is matplotlib. Matplotlib is the most popular plotting library in Python. It is a low-level library with a MATLAB-like interface, and it offers a lot of freedom at the cost of having to write more code here. To install matplotlib, you can do pip install matplotlib. If you write pip install matplotlib like that, you can install matplotlib. We've done that, so what you just go to do is you import. So you import matplotlib.pyplot as plt. We've done that. So matplotlib is a very good package, and it is specifically good for creating basic graph like line chart, bar chart, histogram, and many more. So we are going to go through some of this today. The first one we'll be talking about is the scatter plot. To create the scatter plot in Matplotlib, we use the scatter method. We also create a figure and an axis using plt.subplot, so we can give our plot a title and a label. Subplot, it helps to like the title for this admission chance, and then the x-axis GRE, the y-axis probability. So this, if you focus on this particular line, this scatter line, that is where the argument is called. The first argument, this df GRE, that is the column. So that argument is for the x-axis, and the other argument is for the y-axis. So if you run this, so it gives you. So from this visualization, we can see that as the GRE score increase, the probability or the chance of getting admission increases. Next in line is the line chart. In the line chart, we just use we represent data in our data frame with a line. So if you look at this, we are dropping the column for probability, because the probability, that is the outcome. So we want to know what influenced the outcome. So for the line graph, we don't need to have that column. So that's why we are going to drop it to have this column. And df.shape, that is the number of data in the data frame. Df.shape give you the row versus column. For this is it. So it gives you the number of data and the number of columns. For this particular line plot, you do for columns and columns, and then you plot. This is the x data. This will be on the x-axis, and the df column will be on the right-axis. So if we run this, and this set title is used to set the title for the figure. So looking at this, we can see GRE is the one that is high up. We see tofu, and we see all other data. One thing that we can get from this visualization is that we have values in the data frame that is very far from each other. It means that if we want to develop a machine learning model for this data, we will need to do something we call normalization or scaling. We need to do standard scaling before we continue, because we can see that the big values will influence the model more than the small data. So we need to scale it. For you to create the line chart, as we can see, you create a line chart by calling the plot method. We can also plot multiple columns in one graph, and that is done here by looping through the columns so that everything can be on the same graph. In Matplotlib, we can create histogram using the hist method. If we pass it categorical data like the point column from the admission data set, it will calculate each class. For example, let's look at it. For this histogram, we are using the subplot. The column that we are focusing on for this histogram is the probability column. So we are going to look at, we can see from this chart the majority of the people that were admitted, they are between 0.7 or 0.65 to 0.8. We can use Matplotlib to create a bar chart, and as we can see, we need to call the .bar function. Here we use the probability to get the value count, and then we develop the frequency with the values. So if you run this, it will show you the chances of admission. A bar chart can be created using the bar method. The bar chart is not going to automatically calculate the frequency of a category, so we are going to use pandas value count function to do this. The bar chart is useful for categorical data, but when it has too much category, like more than 30, then it can get messy. This data is not a categorical data, but I've just showed you, so you can use this knowledge for categorical data. So you set the title of the charts, the label, the X label, the Y label, and if you run that, this is what you get. You can also use Pandas Visualization. Pandas is an open source, high performance, easy to use library, providing data structure such as data frames and data analysis tools like visualization tool that we are going to use now. The Pandas visualization make it really easy to create plots out of Pandas data frame and series. It also has a high-level API than Matplotlib, and therefore we use less code for the same results. For you to use the Pandas data frame, of course you install data Pandas, and if you are yet to do that, although I've showed you in this video, you can do pip install Pandas, and after running that, then you can go ahead to import Pandas as PD. After you've done that, I've already done it here, so you can, after you've done that, you can continue to use Pandas for visualization. So the first we are going to do, we are going to create a scatter plot. You can create a scatter plot with just this line of code. If you look at this code, we have two arguments, the column, the GRE column, and the probability column. So, and then you do your df.plot.scatter, and then you give the plot a title, that is admission chances. So to create a scatter plot in Pandas, we call the dataset.plot.scatter and pass two arguments, the X column and the Y column here. So if we run this, as we can see, it is the same thing as we did earlier. If you compare the two, you see that they are the same thing, but with Pandas you see very long code, but with Pandas you just do the same thing with just a line of code. So df is the data frame. You call the plot.scatter, and then the first argument on the x-axis, and then the second argument, and then you give your plot a title. So we can go ahead to create a line chart. To create a line chart with Pandas, it's just the same, but it's a little bit different here, as we for the line chart we don't need the probability column, and also because the research is a very low number, I feel we don't have to use it. One thing is, it's different. You might include it in your own plot and see, and you can write in the column if there is any observation. But after dropping this and then you give the title, you can do it without dropping anything. But if you run this, and then it gives you those lines. As I said earlier, this data, this frame shows that that there is a huge difference in the value of the data set. So we might be thinking of scaling before we develop our model. In Pandas, we can create histogram with the plot.it method. It doesn't require any argument. So all we just need to do is we choose the data frame, we choose the column rather, and for this we want to do the probability column. So you choose the column, and after choosing the column you do plot.ist, and after calling that function you get your chart. And you can as well make more than one plot. You can do so many different plots at the same time. If you want to do that, you have to add more arguments. Subplot equals to true, layout, you give the layout, you give the sizes, and then the bin. So if we run this argument, and then this is what we get. We get for GRE for all the data in the data frame. We can use Pandas for bar chart. So to plot a bar chart, we can use the plot.bar method, but before we can call this, we need to get our data. For this, we first count the occurrence using the value_count method, and then sort out occurrence from smallest to largest using the sort index method. So if we look, you see, for this particular plot, with these bar charts, we are going to focus on the university underscore rating column, and then we get the value counts, and then the sorts, and then we plot. So if we call this argument, it's going to show us how the data set fall with different classes of the university rating. As we can see, more people that are in the rating of most people are in the 3 rating, which is expected. So we can as well plot this as an horizontal graph, and if we plot as horizontal graph, so it's just for us to include h in front of the bar. We call the h argument. We can as well plot data by the number of occurrences. In this example, we group the data by university rating, and then we took the mean of the probability. So let's run this argument and see. So that is it. As we can see, most students with higher rating have most students with higher university rating get higher chance of admission. So we can do the same thing in an horizontal plot by calling this argument, and that makes it horizontal. All we've done with pandas and matplotlib, we can as well do it with Seaborn. Seaborn has a library. Seaborn is a Python data visualization library based on matplotlib. It provides a high-level interface for creating attractive graph. Seaborn has a lot to offer. You can create graph in one line and will take you multiple tens of lines in matplotlib. So its standard design are awesome, and it also has a nice interface for working with pandas data frame. It can be imported by typing import Seaborn as SNS. So if you type import Seaborn as SNS, you import the library. In case you are yet to install, you can do pip install Seaborn, and with that you can install Seaborn and then import it. So with Seaborn, you can create a scatter plot. So for you to create the scatter plot, you need to use the .scatterplot method. We can use the .scatterplot method for creating a scatter plot, and just as pandas, we need to pass it in the column names of the x and y data. But now we also need to pass the data as an additional argument, because we aren't calling the function on the data directly as we did in pandas. So if you see, you need to call the argument GRE and probability. This is x and y, and the data frame you are referring to is df. So if you run this argument, and then it gives you this. As you can see, it's the same thing that we did in is the same thing we did here, and that is the same thing we did with pandas. Sorry, with matplotlib, though it takes a more number of lines with matplotlib. Another thing that we can as well do, we can look at the GRE and the probability. We can highlight the university rating through this EU argument. So let me call it so that you can see what I'm talking about. So you can see after plotting the GRE versus probability, is showing their university rating as well. So as we can see here, even though people have high GRE scores, we can also observe that people with high GRE score and higher university rating are more likely to be admitted than other people. To create a line chart, the SNS.line plot is in use. So the only required argument is the data, which in our case is the column. So if the data is df, here I'm dropping the probability and research column, just as I've done in previous. So as you can see, we are getting the same as we've got in previous. If you look through the matplotlib and pandas, it's the same results, just that it is just a line of code. We can also create an histogram. To create an histogram, because in Seaborn we need to call the thisPlot function. We need to pass it through the column we want to plot, and it will calculate the occurrence itself. So we specify the bin and we put KDA as false. So let's run this argument. This is the argument. You can as well put this as true in case you want. If you put this as true, let's see what happened. So if you put it as true, then it will make this line for you. The next I would want us to do is the bar chart. We can create a bar chart, Seaborn, and it is very easy. It is just one line of code. So you call the can't plot function. So, and if you run this argument, you get this. It shows the data that fall into different categories of the university ranking. We can see that majority of the students that were admitted, their university ranking is 3 and above. Also, we can choose to represent more than one data in one graph. So we can try to look at the relationship between two columns. So if we look at how the TOEFL scores affect the probability, the chances of getting in, we can do that by running this argument, and we can see that as the TOEFL score increases, the probability of getting admission increases. And if we look at this for our model, it looks more, it's linear. It's a linear, so we can consider linear regression and the likes. So the next one, if we compare between GRE and probability, so as we can see also, as the GRE score increases, the chance of getting admission increases. Let's look at CGPA. Also, as the CGPA goes up, the chances of admission increases. Let's look at SOP. I need to look up the meaning of SOP. So it's also the same thing. It's linear. As the SOP increases, the probability increases. Let's check the LOR. Also the same. As LOR increases, probability increases. Let's see how the university rating affects the chances of admission. As we can see, as the university rating increases, it also affected the chances of admission. Let's look at research. So, although not quite much, but it's slightly, but we can still see that more students were more likely to be admitted when they've carried out research in the past compared to their colleagues that has not carried out any form of research. In addition to all this visualization that we've practiced, there are some extras that we can also do with visualization. We can do its map. Although in the last tutorials we used pandas profiling to generate our its map, we can as well do it using matplotlib and Seaborn. So this code here, for you to generate the correlation matrix, you first generate the df.core, that is for the correlation, and then you write this and to get your correlation. But this is very long. You can do the same thing with Seaborn with just this one line of code. So if you run this, you get the same thing with just one line of code. I think I need to add it here that Seaborn is built on top of matplotlib. So Seaborn is like an improvement to matplotlib, so it's no surprise. If you want the data to be written there like that, you can change this to true. And if you change this to true and you run it, then you can see that it shows you the exact figure on each column. I would also like to show you the pair plots. For you to get the pair plots for pandas, you can get the pair plot by running this code. You call this subplots. you first, from pandas plotting, you import scatter matrix, and then this is your data frame, the arguments, and then you choose size, and then if you run this, then it will give you this. You can do the same thing with Seaborn, and it will with just this very small line of code. It's still running. So as you can see that with Seaborn it is neater, and that is why many people prefer to use Seaborn. If you have followed this video to the end, I want to thank you for your time. Once again, the purpose of making this video is to create a platform where we can learn Python together. I want you to comment, I want you to like, and I want you to share this video. I believe there are so many ways to do this. You can share your own method with me in the comment section. Thank you very much, and I'll see you in the next video, where I'll be going straight into machine learning. Thank you very much, and have a nice time.